and I'll be talking about man-overboard rescue capabilities in offshore wind projects. So that would be both during the installation phase as well as the operation and maintenance phase of the project. So I'll go over a brief background on Dacon. Probably a lot of you don't know us. I'll go over the background for why the industry practices exist in oil and gas, as well as the challenges faced in oil and gas, the resources available to the offshore oil and gas sector, and as a parallel, I'll look at the challenges and resources available to offshore wind. There we'll focus on the crew transfer vessels and the smaller service vessels, as well as their equipment. We'll touch briefly on the applicable regulations as of today and some suggestions on future regulations or industry practices. And we'll end with 2 potential scenarios for you to consider. So Daikon was founded in '79 as an offshore diving company. Following the Shellon disaster, we provided safety and rescue training for standby vessels in the 80s and 90s. During those trainings, we discovered there was a lack of efficient man-overboard rescue equipment. So we developed a range of rescue equipment for horizontal man-overboard rescue, and we also introduced the first power-assisted means of recovery. And this product, called the Daikon Rescue Scoop, is now standard equipment on essentially all standby vessels in cold waters. If we look at the background in the oil and gas sector, there are 3 major incidents that have shaped the way that we work with evacuation, man-overboard recovery, and rescue. The first is the Shellon platform collapse in 1980. Second is the sinking of the Ocean Ranger in '82 up in Canada. And the third is the Piper Alpha explosion in '88 in the UK. So Shellon was a 5-legged offshore platform operating in Norway. There was some design or rather repair and retrofit errors, and during a rough storm, one of the platform legs actually broke off and the platform toppled over. Obviously ended up with a lot of people in the water, as well as in life rafts and rescue boats of various sorts. And in the end, there were 89 saved and 123 fatalities. The Ocean Ranger was a drilling rig up in Canada. It too suffered a very severe storm. The storm waves broke a port light in the ballast control room. Water penetrated and short-circuited the ballast system. So once the rig lost control of the ballast system, they lost its stability, and it eventually toppled over and sunk. This was a fairly quick sequence of events, and the standby vessels dedicated to rescuing these people, they were not equipped to rescue people in such rough weather. So unfortunately, all 84 persons on board lost their lives. The Piper Alpha you've probably heard about. It was an explosion in connection with maintenance works on a gas condensate pump. And the subsequent fire was fed by gas and oil from the risers on Piper Alpha, as well as 2 adjacent platforms, I believe. And the entire platform burned out. A lot of people went in the water there as well. And in the end, there were 61 saved and 165 fatalities. So these are the major serious offshore accidents that have sort of shaped the framework that we have today. And in addition to these, you've also heard about a great number of helicopter accidents over the past few years. I believe there's been 5 helicopter accidents in the past 4 years, pretty serious ones. So what came out of these tragic incidents? Obviously, fairly big investigation reports and a lot of recommendations to the industry. I'll focus on the recommendations that relate to evacuation and rescue and recovery. There were obviously a lot of other recommendations on rig design and regulation oversight and that type of thing. Both Canada and Norway, they implemented one national body to be responsible for regulation of oversight. This was previously allocated on several entities. The UK sector, they had the responsibility resting with the Department of Energy, and they shifted that to the Health and Safety Executive, and that was to avoid a conflict of interest, sort of getting away from the industry body policing itself, kind of thing. They also introduced the UK safety case regulations in '92, And that's a very comprehensive piece of legislation that states that any offshore installation needs to be able to provide a safety case to the health and safety executive. And in there, it's essentially a massive risk assessment with mitigation efforts. So for instance, it deals with what happens if you have a fire in control room A, and at the same time you have a short circuit in a different part of the platform. What happens if a scaffolding collapses and you end up with 3 or 4 people in the water? And also helicopter ditchings and anything that could happen. And they need to be able to prove that they can handle these situations in a way that saves the people. Another thing that came out was the increased use of rescue helicopters, both in numbers of helicopters as well as their range. And that was to allow them to stay at the incident site for a longer period of time. They also repositioned the helicopters to be further out and closer to the installations so that they could stay longer time at the accident and rescue more people. There was a lot of recommendations on better rescue equipment on both the standby vessels as well as the rigs. And they introduced mandatory safety training for offshore workers. I believe in Norway at the time of Alexander Shellon, there were only 1,000 out of 4,000 offshore employees that had safety training. And they repositioned all the standby vessels to have to stay closer to the rigs to be able to respond quickly to incidents. And a lot of these recommendations were the same in all 3 investigations, so change happens fairly slowly. There are 8 years between these two of these incidents. So if we look at the challenges that you're faced with in a man-overboard situation in offshore oil and gas, you'll have cold water, at least up here, different story in the Mexican Gulf. It's rough weather, you're far from your shore-based resources. It's a lot of hazardous operations. You're involved in climbing, helicopter transfers, so the side work. And there's also a large number of personnel present on the installations. So any serious incident, it has the potential to become a big catastrophe. If you look at the toolbox that they have available to deal with these situations, you have your rescue helicopters, very much the same that you have in offshore wind projects. In addition to that, you have the standby or emergency response and rescue vessels. Their primary purpose is to be able to rescue people either directly from the water or people evacuating a rig. They also do a number of other functions such as firefighting, often pollution control. They do perimeter control for anything that's drifting towards the rigs. In Canada, they do a lot of iceberg management, which is exactly what it sounds like. If an iceberg tends to be drifting towards an installation, they intercept it early and they tow it a few degrees out of course so it won't hit the installation. And these are positioned close to all the rigs to be able to respond quickly. If we look at what these vessels are equipped with, because this is something that you probably don't see all that much, you have your fast rescue craft, small agile rescue boats, same as you would have on an accommodation vessel or installation vessel. You also have daughter craft that are much larger and enclosed rescue vessels, and they're able to operate with some level of autonomy from the standby vessel. The idea being that the standby vessel can cover a nearby rig and the daughter craft can cover yet another rig, so you can cover more rigs with the same protection but with less resources. You have rescue baskets for situations where you end up with a lot of people in the water. You have scrambling nets for people who are able to climb to safety themselves. They're also used to evacuate people from fast rescue boats or life rafts and that type of thing. Then you have your power-assisted means of recovery, and that's either crane-operated or hydraulically operated rescue systems that are designed for rough weather use. So these are typically the tool that you would use when it's too rough to safely launch or retrieve your fast rescue boat. And the other function that they have is, in a major situation, you might have your fast rescue boat away doing a search in one area. You spot someone from the standby vessel, so you're able to pick them up directly without having to redirect an asset that's already doing something important. So if we jump over to the offshore wind industry, there's very much the same challenges. You're operating in the same waters. You have rough weather as well. It's far from shore-based resources, and here too you have a lot of hazardous operations. In addition to a lot of the ones you have on offshore oil rigs, you also have a lot of crew transfers with CTVs or service vessels. And to deal with these situations in the wind industry, you have your rescue helicopters, rough weather capable, highly skilled crew. These are trained rescue people. The downside is that they have a better response time, particularly as you move further offshore. It will take a while for them to get on scene. And I would imagine it might be challenging to do helicopter rescue when you're really close to a turbine. Say a person gets trapped underneath the ladder, it might be a bit of a challenge. You have your fast rescue craft as well. If you have a installation vessel or accommodation vessel nearby, or a larger vessel that can carry them. Good response time if they're right in the middle of the project. They have good access close to the turbine. They're easily maneuverable. And these are boats designed to rescue people from the water, so it's fairly easy to rescue someone. But as I said, they require a larger vessel on site, so perhaps not the obvious resources to have during the maintenance phase of a project. They're also weather dependent. You need to be able to safely launch and recover them. And more so probably if you're jacked up with an installation vessel. Typically on a standby vessel or any type of merchant ship, when you launch an FRC, you make a lee so that it's easy to launch and recover the fast rescue boat. With the jack-up vessel, you don't have that choice. The wind might be coming from the entirely wrong direction. You also have your shore-based resources in form of the Coast Guard and search and rescue vessels. Again, a great resource with trained rescue people, but you have a bit of response time for them to get out. Finally, you have the one that I'm going to focus on here is the wind farm support vessels and crew transfer vessels. From what I understand, they're usually on site in a lot of the installation phases as well as during the maintenance phase. So it's a resource that you have very often on site when the incident occurs. It's also not unlikely that the incident is related to operations of the crew transfer vessel, transfer to the turbines, for instance. These are probably the closest thing you have to the standby vessels in the offshore oil and gas industry. But their capability very much depends on the vessel design, the equipment on board, as well as the crew training. So if we look at what they carry on board to deal with this, they have your rescue ladders, either fixed or portable. It's an inexpensive tool, but it requires the distressed person to climb to safety themselves. And it might be difficult with high freeboards and rough weather. And we see these crew transfer vessels, they're getting bigger all the time, and they're getting higher freeboards to be able to cope with tougher weather conditions. I don't believe this is used much as the single source of rescue anymore. This is more of a secondary means nowadays. You also have your rescue poles or rescue slings. And this is essentially a telescopic handle and some sort of a loop in the end to catch the person. So what you do is you deploy it in the water, and then you try and maneuver it around the person so it rests beneath his arms, and you lift him up with normally a manual operated davit, a sailboat winch or block and tackle system. They're inexpensive as well, and they can rescue an exhausted or possibly unconscious person. But there are some weather issues. If you're having some, say you have 2.5 meter seas, and there's 3 or 4 meters from the railing to the sea, there's going to be a bit of a challenge to get this small loop around the person. Particularly if they're unconscious, they might also be standing in the water. Not all persons that are going to be rescued, they rest calmly on top of the sea. And it's a vertical rescue technique. This is something that the whole rescue industry are moving away from. You want to do horizontal rescue to avoid circumrescue collapse, as well as worsening any back injuries or major injuries that the person might have. It has a limited reach. There's only so long you can make this pole while still being able to control the business end of it. You also have rescue nets. These are usually, say, a meter, perhaps 1.5 meters or 2 along the ship side. They have a fairly narrow rescue opening of 0.5 meter or perhaps up to 1 meter. The way you operate these is that you get a hold of the person with that rescue pole or rescue sling. You maneuver them over and into the rescue net, and you keep them in position there while at the same time hoisting with a block and tackle or sailboat winch typically. It's a horizontal rescue technique, which is good. They double as a scrambling net, so people are able, they can climb to safety themselves. And it can work with an unconscious person. Same thing here with weather limitations. This is a narrow opening, and it's a small net, so you need to be able to keep the person positioned in there while at the same time hoisting. I would guess that in most instances this would be a two-man operation. You need somebody to maneuver the person with the rescue pole and one person to hoist the rescue net. So just to give you an idea of why we say that this might be challenging in rough weather conditions, this is a training exercise, nothing out of the ordinary. This is probably around 3 meter seas. This is a net that's 7 meters along the ship side and 10 meters wide. But imagine doing this with something that's 1.5 meters, maybe 1 meter, and that has an opening of 0.5 meter or 1 meter. So if you look at the way this person moves around in the waves, just catching him with that rescue pole and then keeping him in place in the rescue net while you hoist it could potentially be a challenge in this weather. The other thing we have is the rescue scoop or power assisted means of recovery. It's a rough weather rescue technique. It has some. It doesn't matter if you have high freeboards because you operate with a crane. It has a large rescue reach, typically 4 or 5 meters from the ship side. It's a horizontal rescue technique, and it doesn't matter if the person is conscious or not because he's not aiding in his own recovery. So this is a shortened down version of a 3-minute rescue that we did during a sea trial on a vessel prior to delivery. The way you operate it is the crane driver maneuvers the crane, deploys the net over the side, and at the same time the master maneuvers the vessel to get the person within reach of the net. So the crane is slewed forward, so you saw that it was deeper in the forward end and shallower in the aft end, and this is to avoid the next big wave taking the person straight through the net and out on the other side. So once the person is in the net, you hoist quickly on the winch to get him free of the following waves, and then you can slowly start to gently roll him up to the deck and to the rescue position. The other benefit of this is, as long as you have a remote operated crane, or you are able to control the crane operations at the same position as the vessel maneuvers, it's even possible to do this with just the captain doing the rescue. So on these vessels, for instance, there's a maneuvering position on the starboard bridge wing, and you have a remote to the crane. So in that extreme situation, if it's a two-man crew, he can actually do the rescue. More costly, of course, and it requires a crane or a suitable lifting arrangement to operate it. Just briefly on the applicable regulations that we have today. There's not that much that regulates these smaller vessels. They normally fall under various national standards, such as the UK Workboat Code or Brown Code. It's in that you have some wording that you need to be able to rescue any person from the water, and you need means to take him to the rescue equipment. It doesn't say anything on if the person is unconscious or not, and it doesn't say anything about the amount of crew members that you can use. There's also some in the DNV high-speed lightcraft rules for those vessels classified under that. And in addition to the wording in the Workboat Code, they also state that you need to be able to rescue a helpless person. And that's a fairly important definition, because rescuing somebody who can help themselves is a bit different from rescuing an unconscious person. In addition, they state that you cannot leave the bridge unmanned during the rescue, and that the place where you maneuver the vessel needs to have a good overview of the rescue area, so you can actually see what's going on as you're maneuvering the vessel. But in general, we've not been able to find that much regulation that talks about man-overboard rescue for these smaller vessels. There are two ways to sort of improve on that, those regulations or industry standards. One is regulatory changes. It's a slow process, and unfortunately it's often preceded by major incidents, such as the one we started with. The other one is requirement for project stakeholders, such as some of yourselves, essentially risk reduction. And either that can be through putting more wording in the charter contracts for these smaller vessels that they need to be able to rescue somebody in a certain fashion, or in the overall construction and maintenance contracts about how rescue is to be handled. A few things that we argue should be important parts of the industry standard or regulations if that evolves. It should be a requirement that you do horizontal rescue. It's not good to rescue somebody in a vertical position such as that sort of rescue sling and davit situation. The equipment should be operable with the minimum amount of crew, less one. The reasoning behind that being that it might well be one of the crew members who end up in the water. Should be tested in expected weather conditions. It's very easy to make anything work in flat seas and a sunny day. And there should be an industry standard on total rescue time. This might exist already, I've just not been able to find it. And that should be based on the expected water temperature as well as the protective garments that the technicians and crew members are wearing. You have this in oil and gas. They state, for instance, for a helicopter ditching, the standby vessel needs to be able to rescue all potential 21 persons within 2 hours in 7 meter seas. The reasoning behind the 2 hours is that the helicopter suits are designed for 3 hours survival time, so you need a bit of safety margin. The reason behind the 7 meter figure is that that's the highest operational envelope for the helicopters, where they can sort of safely ditch. Man overboard drills should be part of charter's health and safety inspection. They might be already. There should be a requirement for the drills to use mannequins with human proportions and proper weight. It's very easy to rescue a coverall filled with fenders and believe that you have this man overboard scenario under control. It's very different when you end up with someone in the water who might weigh 100 kilos with wet clothing on. And this is sort of the challenge that we see both in shipping and offshore as well, that these drills, they're fairly often performed on a sunny afternoon in June with flat seas, and let's have a drill. So it's important to practice as close to the expected real conditions as you can. So finally, I'll give you two scenarios to consider. One is a two-man crew operating a CTV to transfer technicians in the North Sea. The weather takes an unexpected turn for the worse. As they're trying to pick up technicians, you get 2 to 3 meter seas and strong winds. The deckhand slips and falls overboard. And in that fall, he appears to hit his head, and he seems to be unconscious. So now the skipper needs to find a way to rescue his colleague, while at the same time keeping in control of his vessel and radioing the distress. So this would probably prove a bit of a challenge. We actually had this a few years back on a small service vessel with a two-man crew. There was a health and safety inspection from one of the major developers, and they said, let's hold a man overboard drill. So the deckhand, he started preparing the rescue equipment, and the inspector from the charter just said, no, you're the guy in the water, so the master, please proceed with the rescue. And that obviously caused a bit of unpleasant wiggling and thinking about how to do this. So they came back to us and said, you've experienced from the standby vessels, can you look at doing something for these smaller vessels as well? So we provided them with one of these crane-operated rescue scoops. In addition, they made changes to the vessel so you could control the crane in the same place that you could maneuver the vessel. And following that, the master was able to prove that he could perform a single-handed rescue should the worst-case scenario happen. The second, I don't have a fancy solution for the second one, but imagine a helicopter crash during technician transfers, either to an installation vessel, or I've understood that you're looking also at doing hoisting transfers to the turbines. So essentially you end up with 10 people or something like that in various conditions in the water, possibly near a turbine. So how would this be dealt with today? Would it be a helicopter response from shore side, and what's the response time? Can they take all 10 people, or they need to take 2 turns? And what's your other resources that you can use? That's about it. Thank you, and I'd be happy to answer any questions.
Thanks a lot. Are there any questions? No. I have one. defense industry, which is very high health and safety standards. What's your impression of the standards in the offshore wind industry, and have you seen demand for these kind of equipment already?
Well, we have fitted this on a number of vessels already, but it's more been on an owner's request type of thing. The challenge with these vessels is that they sort of fall between regulations. A lot of them are classified under the UK Workboat Code, something that's that's designed to cover a whole range of working vessels, commercial vessels in a smaller format. And most of those are working near to shore side, and it covers things like pilot vessels and similar. And to apply that to wind farm projects that are quite a bit further offshore and with very different circumstances, that's difficult. But when you're building a vessel, you only meet the regulations. So it's tough to get an owner to put in higher requirements than what's on the checklist for the regulations.
Okay, thank you. Anyway, fatalities will be fatal.